Welcome back to the pod. My name's Thomas,
My name's Erin.
I'm Peter.
and we are three computer engineering students at Georgia Tech. Today, we're stepping inside the black box, and I'm not talking about an airplane flight recorder. I'm talking about the two most complex systems we've ever tried to map, the human brain and the deep reaches of space. So today, we're going to explore how machine learning has evolved from a tool that suggests what movie you should watch next into a universal translator for the universe. We're looking at how code is now bridging the gap between raw biological noise and digital commands, and between massive cosmic data and the discovery of new worlds. If you've been following the tech world lately, you know that we've hit a criticality point, an inflection point. We've moved way beyond simple supervised learning, where we just need a computer, 1,000 labeled pictures of cats. The real recent breakthrough is the rise of scientific AI. We're seeing the emergence of things like deep O-nets, which are deep operator networks. These aren't just chatbots, they are models that can solve complex physical equations in milliseconds, problems that used to keep supercomputers running for weeks. But here's a piece of trivia that really blew my mind while we were prepping. We always hear that AI is modeled after the human brain, but the irony is that modern AI is actually becoming better at reading your thoughts than we are at understanding how the AI itself works. Stick around because we're going to talk about a study where AI decoded handwriting directly from brain activity at 90 characters per minute, nearly the speed of natural conversation. And later, we'll see how a tool called PPDONet is simulating 500 planetary systems on a standard laptop in the time it takes you to grab a coffee.
Recently I actually did some research for my paper for Computer Science 3001 class about ethics, and recently I did the research on a neurotechnology called Neuralink, and what they create are something called brain-computer interfaces. And basically, these Neuralink, what they do is they create small chips that get implanted into your head and brain, called a brain-computer interface. And it actually has these thousands of high-resolution, like ultra-thin electroneedle threads that record neural activity that goes around in your brain.
Wow, that's really cool. So does ML AI come into play for this new technology?
Yeah, of course. Actually, machine learning is actually used by algorithms and neural networks, such as the support vector machines used by Neuralink to decode what neural activity into digital commands so that people can watch videos or even click through the internet just by using only your thought.
Yeah, actually, I found something similar online which is very interesting. I found that the technology used by Neuralink is also used in some elementary schools in China. Students wear headbands which have three electrodes on them, and one of those is on top of their forehead and the other two is on the back of their heads. These electrodes measures electrical signals from their brain, and machine learning helps with analyzing those signals to help teachers to see which students are paying attention in class.
Yeah, that's pretty interesting in my opinion, but it's also a little scary.
Yeah, no, I agree. That's kind of, yeah, just the thought of that is like, where are we going to go into? But then, what other parts of AI have also been developing more recently besides Neuralink?
Actually, there is a lot going on right now. For example, one big change is that AI isn't just something that you ask questions anymore. It's just more than that. It's starting to feel like a helpful assistant. It can help with coding, emailing, processing documents, and even can help you with some multiple step tasks.
Yeah, and I would say that AI is just becoming more text-based, more than just text-based. It can now work with images, audio, and even video. So instead of you as a user only typing to it, you can show the AI agent things, you can talk to it, and you can understand the different things you're trying to learn about in different ways. Another big change is that companies are trying to make AI faster and cheaper to run. So it's not just about making the biggest model, but rather about making smart and efficient systems that still work really well without using too much power or money.
Then wouldn't there be any concerns about safety?
Yep, Aaron, I'm glad you mentioned that because actually there are a lot of safety and rules. Because, as AI gets more powerful, people are going to be focused on more how to control it and how do we test it so that we make sure that this technology is being used responsibly by the people. And overall, since AI is growing in three main ways, which are it becomes more useful, obviously, and now we're working with more types of information, not just like Thomas said earlier, not just photos. You can get videos, audios, and the third is we need to make sure it is used and it stays safe and reliable to use.
Yeah, so clearly AI brings a lot of new opportunities because it can help people to work faster, learn easier, and focus on more important thinking instead of just repetitive tasks.
Yeah, and for us as students, it can be used as a study partner. So It can explain difficult topics in simple terms. It can help with practice questions, or just giving feedback on writing. And then I guess for the future, when we become professionals in our field, it can support tasks like drafting emails, organizing ideas, analyzing information, and even learning new skills more quickly.
Yeah, honestly, the key isn't actually to rely on AI to do everything for us, but instead, we need to use it as a tool that helps boost our own capabilities that we have as people. And since people who learn how to ask good questions, they can use the AI more responsibly and actually in a safer and better manner, which saves their own time and it actually improves their efforts and their work, yeah.
Yeah, I definitely agree with your view of AI as a productivity boosting tool.
Yeah, so I guess pivoting to the future, where do we think AI is headed?
Yeah, I think AI is actually becoming more integrated into like the life of everyday citizens. As it might not always be obvious, but it'll actually be behind a lot of the tools and systems we use. Even so now, a lot of companies such as AWS and Amazon are integrating AI agents more and more into their work style so that they need less people to work on it because AI can easily replace them at this point.
Yeah, and we'll probably see AI becoming more personalized. AI will understand the individual needs of people and adapt to each person. This can actually make learning, working, and daily life more efficient.
Yeah, and at the same time, that probably means people will need to understand AI more, not just use it.
Honestly, that's exactly what I'm thinking, Thomas. But knowing how AI works, even at the most fundamental basic level, will be really important so that people can use this technology responsibly and make decisions that are more informed before possibly going down a bad rabbit hole.
And I think one of the biggest challenges will be to make sure that we are protecting the people while AI is rapidly improving.
Yep. And so overall, I would say to summarize, AI has a lot of potential, but it's really up to us and how we choose to use it.
Exactly, and that's what makes it such an exciting but also important concept at the same time. Speaking of neurotechnology, we actually have a specialist in neuroscience right now with us.
Hi, my name is Anjali. I'm a neuroscience major at Georgia Tech.
Nice to meet you, Anjali. From your perspective, what's the most surprising way machine learning has changed the field of neuroscience in the past few years?
Yeah, so that's honestly a really good question. And the most surprising shift that I've seen so far has been like describing brain activity to like actually decoding it. And so like for many, many years, neuroscience is more about like asking what part of the brain is active. But now with machine learning, we can ask like, what is this person trying to do or say? And a good example of this comes from a 2021 Nature study, and that's where they implanted electrodes into paralyzed patients, and this recorded neural activity from the motor cortex, and they used machine learning models to decode the signals, and this allowed the patients to actually like write sentences by just thinking about the handwriting, and this showed that like AI can translate thought into language or text in real time, and the machine learning was able to translate this into text at like around 90 characters per minute, and that's pretty close to the natural communication speed. And this also kind of relates to the Neuralink that you were talking about earlier. And so yeah, the biggest change is probably machine learning has helped us be able to translate thought into language.
That sounds really interesting. So then, from your perspective as a specialist, do you believe that technology such as created by Neuralink, for example, do you believe that will be able to have a bright future ahead of us, will helping people with neurological disorders or even physical disorders such as paralysis?
Yeah, definitely Neuralink and another kind of technology similar to that would help for sure in like just individualized patient care and individualized like medication, because I feel like it'll be able to do something similar for these paralyzed patients where like they could actually be able to write just by thinking.
Alright, so speaking of that, so then a lot of AI models are actually inspired off the human brain. Do you believe that the modern neural networks are actually getting closer to how the brain works, or are we still like far off from it?
Honestly, I think we're still a little far from it just because I feel like it's still pretty new. But neural networks are more inspired by the brain in a very like loose way. And this is like because they learn patterns, they use layers, but that they're also missing a lot of what makes like the brain unique. And the brain is like constantly learning and it's shaped by experience. So it uses chemistry and the energy efficient, and it's deeply connected to like the body and the environment. And I feel like a lot of AI systems can't capture that yet. So while AI can sometimes like approximate brain activity really well, it doesn't necessarily mean it'll work the same way as a brain. But this could definitely eventually happen in the future.
Great, thank you so much. All right, so speaking of that, so to build off that question so far, where does AI still fall short when we're trying to model and understand the brain?
I think that one of the biggest limitations is that AI is really good at like predicting and not necessarily explanation. And so like a model might be able to decode speech or like predict behavior from brain activity, but it doesn't necessarily mean that it's gonna understand the underlying biology or like mechanisms behind that explanation. And I think a lot of people have been seeing this problem just using like ChatGPT and stuff like that. And there's also a lot of issue with like generalization, and models work really well in one data set or like one person, but they struggle a lot when like the conditions are changing. So I think we're definitely getting better at reading the brain, but it's still far from like truly understanding like how it works.
So then, building off that, so do you share any concerns as a final question that researchers may become over dependent or too trusting on the patterns that are found by machine learning?
Yeah, I think that's a big concern that a lot of people are talking about right now, and machine learning can like find patterns that are meaningful, but it's actually just like noise, and especially with a bunch of this like complex brain data. So I think there's a risk that people might treat those models as like definite answers and like kind of just trust that. And so especially because they're very powerful like statistical tools, I think the key is just to stay cautious, validate your results, and like use independent data sets, and also just remember that like even though the model does work, it doesn't mean it's necessarily telling you the truth. So just like be careful with what you're reading.
Great, thank you so much for your help today.
Yeah, of course.
Yeah, so after talking about neuroscience, which is more on a microscopic level, let's zoom out all the way into our universe and talk about astrophysics. So here today we actually have an astrophysics specialist.
Hi, I'm Shannon. I'm an astrophysics student here at Georgia Tech.
Yeah, so Shannon, because space generates large amounts of data, how critical has machine learning become in handling that scale?
So that's actually a really interesting question. So I recently read this article, and basically back in 2023, Xunyuan Mao of the University of Victoria and their team developed a tool called Protoplanetary Disk Operator Network, or PPDONet for short, and it basically predicts the solution of disk-planet interactions in protoplanetary disks in real time, which, to put that in simple terms, protoplanetary disks are the clouds of space dust in which planets, stars, all that sort of things form, and being able to predict that with machine learning is very, very helpful. So in this article, Mao was talking about how modeling a large number of disk planet systems or exploring the parameter space of their interaction is very expensive. And as the number of observed disks continue to grow, modeling all of these observations using simulations is becoming impractical, in their words. Currently, PPDONet is the first and only public tool that is able to accomplish this problem, and it can predict a structure of 500 disk planet systems in just a few minutes on a laptop, which is so many orders of magnitude faster than conventional numerical simulations, which would take days, if not weeks, with these old supercomputers, and now it can happen in less than a second for anyone to use on a public domain.
That's really insightful, thank you. Could you walk us through how AI might help us look through noises to find any meaningful and useful cosmic signals?
That is also kind of a hard question to ask, but it's pretty interesting. Honestly, I currently, if you want to look through cosmic noise, background radiation, you kind of have to like manually filter it out, but now AI basically does the same process as a human. It learns from humans. That's the whole point of machine learning. It just now goes so much faster, like significantly faster.
Great. And given all of this AI development, I want to pivot to, I guess, some of the more negative side of things. So what are some possible risks of relying too heavily on machine learning in astrophysics?
I mean, yeah, that's a question everyone's asking nowadays with AI is, what's going to go wrong? Like, are we going to end up like the Terminator? Are we going to have some society where robots control us? But obviously, I don't know for certain what's going to happen in our society. But from what I've seen in astrophysics, it's pretty much the same as other fields. Like, there's obviously a risk of humans becoming lazy if there's an over-reliance on AI, maybe a lessening in critical thinking abilities. But overall, I've mostly seen AI and machine learning be a very useful tool for speeding up problems and speeding up calculations that are currently too complex for a human to generate on their own. Like, they're not able to have independent thoughts. So now they're just helping us with that.
Okay, cool. Now, I guess I'll pivot to, more of the future side of things. And so could AI ever independently generate new theories of the universe, or will it always be dependent on human guidance or interaction?
So that's kind of like what I was just saying. Basically, I do think that AI will help us evolve our knowledge, help us improve research much faster, at a much faster rate than we have been, but I don't think it's going to be capable of generating independent thought, independent theories of the universe. So I guess, at least for my job, I hope that it will always need human guidance, or else I'm in the same situation as a lot of CS majors are right now. But yeah, I guess I really don't know, but I hope not.
All right, great. Thank you, Shannon, for coming on the show. I definitely learned a lot, and I hope you guys did too.
Okay, so we explored a lot of things in this episode, from reading brain activity to simulating planetary systems. But we see that a similar idea keeps showing up, which is that machine learning is used in very different areas but ends up doing something similar. It helps to turn complex information into something practical. So it is clear that machine learning is starting to change how neuroscience and astrophysics approach problem solving. For example, in neuroscience, instead of only looking at brain activity and then trying to interpret it, now researchers are getting better at linking those signals to actions or communication. But fully understanding what's going underneath the technologies of brain-computer interfaces and neural decoding is still a mystery. On the other hand, in astrophysics, something similar happens, but on a much larger scale. Now, problems in astrophysics can be estimated using machine learning and a lot faster. This can help with testing more ideas and working with more data. But it is not true that faster results mean a deeper understanding. So in both fields, AI is acting like a translator, as it makes complicated systems readable, but we still need human interpretation. Maybe that's the main takeaway. And machine learning is helping us to ask better questions rather than giving final answers. As it keeps developing, the most important challenge will be to make sure that human understanding is still a part of the process. So it's not just about building better models.
Alright, thank you guys all for listening to this week's episode of the Black Box and learning about machine learning along with us. Now, Thomas, can you send me the AI that people are actually using to help with their studying?